Good afternoon, everyone. My name is Alex Brockett. I'm one of the transportation engineers for Portage Engineering. We're going to take you through a little bit of a progress report on what we've been working on so far for this project. So I'm going to start off giving some general project information, then we'll go into our individual expertises, what we're doing there. So first off, this is just general site overview. So we're working in this blue rectangle here. We've got those purple lines are grade lines. They're separated by 1 foot, so this is a 1 foot change in elevation. So this is a relatively flat project area. And then up here in this corner, we've got this orange and blue are where the wetlands and floodplains are. According to FEMA, this was all found on a GIS hub for Lake County. General challenges that we have here are avoiding those wetlands and the FEMA floodplains, trying to not discharge any of our wastewater into there, and trying to avoid building on those. We're trying to avoid any existing structures, so any of those telephone poles that are running through, or any existing train lines or gas lines. And we don't have a structural engineer for our project currently. We've got myself and Josh are on transportation, Jacob is on water resources, and Ziamara is environmental. So we're kind of guessing on the uses for the buildings, and we don't have any actual structures person to make those for us. So now diving into my transportation part, I'm going to go over what I currently have done, then I'll give a little overview of what I'm working on currently, and then I'll go into what the plan is moving forward. So right now I've gathered design criteria for the parking lot and the road. I've also developed 2 alignment alternatives and considered requirements for the parking lot and preliminary parking lot design. So first thing is my roadway design criteria up here. This table on your left is what I have for roadway design criteria, and I have justifications on the values. I decided to go up with a 25-mile-an-hour road. This is because the surrounding roads are primarily 30 and 25 miles an hour. There's a main road not too far away from the site, so to try to avoid people trying to cut through our site in order to get over to that main road, I decided to go with 25 mile an hour to try and dissuade that a little bit. And we went with an urban local street. This is because that's pretty similar to the rest of the classifications around there, so that led me to IDM table 53-9. For the parking lot design criteria, it's a lot of looking at the city ordinances for Crown Point. So they've got requirements for how many spaces are needed for residential stuff and for office building. I decided for the building that I'm going to be working off of 20,000 square feet of office space on the bottom floor, and then on the second floor it would be apartment spaces. So I found about 1,200 square feet was a typical size for an apartment, divided that out, and that gave me my number of units, as well as using the 1 space per 200 square feet of office space. So we're going to end up needing about 140 parking spaces, so this is going to end up being a pretty big parking lot. There's also some guidance in the city ordinances as far as minimum size for the lot width and for the space of the travel lane in the lot. Moving on to the alignment alternatives. Right now I only really have a basic general idea of what I'm looking at for alignments. This is because I've done a lot of work with the parking lot stuff, because Jacob has needed that for his water resources stuff. Generally what we're looking at here is this sort of an alignment tying into that road there. Josh is likely to be making a road to come up north to meet him with mine there. So this is just a really general idea because I've had a large focus on the other things for our water resources engineer. So what's being worked on currently, we're finishing up that preliminary design, developing those alternatives, and one of the things we're looking at is the manual on uniform traffic control devices. I'm going to refer to that as the MUTCD from here on out. We're going to be looking at that for warrants for our intersections, as well as gathering information for a traffic impact study. So for MUTCD, I'm looking at unsignalized warrants here. Josh will go over some of the warrants that are going to be needed for signalized, because I'm tying into roads with lower traffic volumes. So basically what we're going to do is we're going to look through some of these warrants here, and as long as those are met, you meet the requirement to consider that as an alternative for your design. So this is for unsignalized, and like I said, Josh will go over signalized a little bit later. As far as information for the traffic impact study, we've gotten some turn movement counts from Professor Grossman, as well as we've started to look at trips generated and potential pattern changes like I was talking about earlier with if anyone's going to try and cut through that road to get back over to the main road. So the plan moving forward for me is developing alternatives based on the combinations of alignments and MUTCD warrants, and then completing the traffic impact studies to allow me to select an alternative based on what's going to work best as far as level of service is concerned. Now I will pass it over to Josh, and he will go over more transportation stuff and project management.
Thank you, Alex. I'm Josh. I'm a transportation engineer along with being a project manager for Portage Engineering. And for my side of transportation, so far I've completed the general design criteria, the roadway, which I then went into the building and deciding what usages I wanted to use. Since mine is different from Alex's, I can do mine a little bit differently and get a different, pick different stuff than him. And then I decided to use picked my different areas for the usages, and then from that I went into my parking lot design and came up with the spaces required for that. And looking at my roadway design criteria, I went with a urban local street and chose the design speed of 30 miles an hour. This looked like a average speed in the area, so it seemed fitting. And then from there I used the IDM figure 53-9 to pick out the rest of my design criteria and values. And looking at my parking lot design, I started off with the building usage, and I'm mostly all just assuming these usages and area allotments. Use that in looking at the Crown Point parking requirements, was able to calculate the amount of parking spaces I generally needed, along with some bicycle and ADA parking. And now looking at my work that I'm currently working on, looking at my alternatives, figuring out the alignments for my alternatives and profiles as well. Currently looking to tie into this road here at this intersection and then carry up into Alex's road. And then another alternative was about in between these two intersections, and again, just going up into what Alex's alignment will be. And then from there, I was looking at the parking lot, finalizing that design, and getting those drawings and layouts figured out. And for my future work that I'm planning on is gathering traffic data, so doing traffic impact studies, looking at the additional trips generated by this addition, and the growth factors along with that. And then looking at my intersection alternatives as well, utilizing the MUTCD to decide whether stop signs or signalized intersection would be a better fit, along with using V-stroke to look at the level of services to help better my judgment and decisions. And then, as Alex said, this is the MUTCD traffic signal warrants that I'll be looking into. Basically, I'll just be going through 1 through 9 of all these warrants and checking off if they're warranted or not, and if it justifies a traffic control signal. And I will pass it on to Jacob.
Hello, my name is Jacob. I'm the Water Resources Engineer for Portage Engineering. I'd like to tell you a little bit about what I've been working on. So a little overview of the scope real quick. The objective is to develop low-impact designs to manage stormwater and from the road and structures per client specifications. So that includes reducing the total metal load by 60%, the total solids load by 80%, and then infiltrating at least 1 inch of runoff from impervious surfaces. This is also that 1 inch is mandated in Lake County stormwater technical manuals that worked perfectly for that. So I will be designing management for water quality and flood control volumes for the development site and the roadway runoff. So this is not storing, at least for the flood control volume, not storing the entirety of the contributing watershed water that falls on there. We're focusing on the roadway and structure limits, but I will have to include a diversion for water that runs through the site from those contributing watersheds. So with that, some current work that's been completed is site investigation and research, water quality volume calculations, a pre-development flow rate for flood control, and water quality BMP research. So for site investigation and research, I used the NRCS web soil survey to grab hydrologic soil groups. So as you can see over here, most of this area is soil group D. You see here it says C over D. C is specified for when the soil is completely undrained, and then that D rating is for drain or saturated soil. And so I'm assuming saturated soil because just for a conservative estimate, and that has a very low infiltration. So for the water quality volume, for low impact design, this is the equation that Lake County specified to use. So that's where I got these numbers down here. Around 2,600 for the parcel, 3,300 for the road. I assumed around 30,000 square foot of grass cover in good condition for that parcel, and around 55,000 square foot of impervious cover. That includes 20,000 square foot roof cover and 35,000 square foot for the parking lot. And then I used Tier 55 to get that aggregate curve number, just to not have to do as many hand calcs. Potential water quality BMPs that I will be looking at for the parcel: permeable pavement, rain gardens, green roof, infiltration bed, and then for the roadway, tree boxes, infiltration trench, and then possibly constructed wetland off to the side for that. I'm looking at these specifically for their high infiltration and ability to remove contaminants in the water. For flood control, I use the Civil 3 catchment tool to denote these contributing watersheds. Like I said, again, not all of this water is going to have to be stored, but it will have to be diverted off-site. And I was able to use that tool to get lengths and slopes for sheet flow and shallow concentrated flow. I was able to plug those into TR55 and get a pre-development flow rate, outflow rate. With that, some flood control alternatives. Wet basin, these are excellent for volume reduction by infiltration and evaporation. They're multi-use, so recreation, wildlife uses. However, they do have a large footprint. There's mosquito concerns and safety risk, deep water, so there'll have to be some sort of protection around there for that. Or dry basin. Now these are smaller footprint, which is nice, lower cost, which is nice, no mosquito issues. However, they have comparatively poor volume reduction, only infiltration, and then they clog if the sediment is not removed, so there's maintenance costs associated with that, and potential erosion at the inlet or outlet if it is not armored. So some current and future work. So for flood control, to develop wind TR55 models for the wet and dry basins, and get that post-outflow, post-development outflow to 0.2 cubic feet per second per acre. That's per Lake County specifications. For water quality, BMP sizing calculations, and then developing those alternatives. And then finally, finalizing design alternatives. So combining the flood control and water features into full design alternatives, doing a cost estimate, and then evaluating alternatives for a final proposal. Those will be evaluated up to cost, their ability to store water, and then for flood control, infiltration, and contaminant removal. So with that, I'll pass it on to Zia Parma.
Thank you, Jacob. So moving on to the environment component of our mixed-use business park. I'm tasked with designing a gravity wastewater collection system. And so what that entails is doing a site characterization of the site. So that's looking into like what soil types it is, where are the floodplains, and then making sure to avoid the wetlands. And then based off of our proposal that we proposed, we did two parcels. The first parcel is 1.5 acres, second parcel is 2 acres. And so I just had to figure out the water demand for those. The tricky part was that because we don't have a structural engineer, I mostly just gave a lot of different alternatives to what the usage could be for the 1.5 acres. Because for the second parcel is where we're gonna have our building. And so I have an idea to do for that one, but for the first one, I just had to do different alternatives for what the use could be for that. So then for the gravity wastewater collection system, a lot of that was just looking into the different pipe materials once I figured out the flow rates, and then figuring out what could be the diameters for the pipes used in the force main and the lift station that delivers the wastewater flow. And so I started off the web soil survey, similar to what Jacob did. And so for the most part, a lot of land has pretty poor drainage. And so we would have to avoid a lot of the bottom part and move more towards the top. And so that could be a problem for when we design the collection system, lift station, because that could cause a lot of infiltration in the system. Like water going into the pipes, potentially because it's not being absorbed through the soil. And then another thing to note is in this soil group table, for the most part, the slopes are pretty minimal, between 0 to 6%. So the runoff velocity is going to be pretty low, and erosion risk is pretty small as well. So for the water demand for the first parcel, I decided to do 3 different alternatives for what the use could be, at least until we figure out what to do for the second part of the semester. But I decided to do a low, medium, and high, and that's based off of the occupancy, how many people are on there, as well as the use of water, like how much wastewater is going to be produced in each of these. So the first one is mostly like offices, public restrooms. Second one is like a shopping center, so more people. And then the high one's like a department store, an office, and a public restroom. So those are all just 3 different types, and I incorporated total flow that incorporates infiltration and flow into all of those 3 options. And then for the second parcel, I took a different approach. I decided to do it based off of acreage. So the 40,000 square feet goes to about like 0.918 acres. And so I just used, because we're doing 2 different floors, it's a 2-level building, so I assumed we're gonna probably do like a 0.5 like fraction for both commercial and residential, because the EPA has like a range between like 0.5 and 0.5 for commercial and residential, all the way to like 0.3 and 0.7 for each of those. So I decided to just go on the lower side of that. And then I continued doing the area calculations, and then I did like an estimate of employees, and most of that was based off of like, was a general idea of how many employees could fit in a building like that, especially like for like offices specifically, since we don't have what we're gonna use for like how many bathrooms are gonna be in there, or how many, like if there's a break room that's gonna change, if there's gonna be a sink in there, that's gonna add more like wastewater. So I just did it mostly based off of like square footage. And then I also mentioned process allowance. That's mostly more for like the residential side. Just to think about like if there's gonna be, just to give a bit more allowance in wastewater flow that could happen. If there's like more people in the place, or there's a party going on, or there's more wastewater being generated. And so I also incorporated infiltration and inflow into that as well, and below is like an estimate of what the new flow is going to be for that parcel specifically. And then this is a combined flow, so I did the building flow and I combined it with each different level. So as I mentioned before, it's all dependent on occupancy and usage. And so I calculated the average flow, the max flow, and then the peak flow. And then I used values of 2.2 for peak day, and I think it was like 5.3 for the max. And then current and future work, still working on the lift station design. I've broken it down into figuring out what materials I'm gonna be using. So I'm gonna just be looking at like the ASTM like guidelines and manuals for like different pipe materials, and then based off of that, I'll be using Manning's equation to figure out what is the allowance, like what's a good pipe diameter to use for each of those. So I'm still continuing with the lift station and the force main design on that side, and making sure that I'm compliant with the Indiana State Department of Health specifications and clearances. And then I'm also going into like, apart from like pipe selection and sizing, also location. And so since we are still looking at where we're gonna locate it, we know it's gonna be in a high point. I'm still trying to play with the numbers of what would be best to deliver our wastewater flow to the existing sewer lines. And then kind of going along with that, these are just the guidelines in design. These are the design criteria. This table specifically is the IDM justification. So that's mostly just looking at more so like the lift station, a little bit of like the force main in there as well. So those are gonna be what I'm gonna be basing it off of, once I figure out which diameter I'm choosing for the pipe. So the diameter is ranging from 6 to 12. So I'm doing like 6, 8, 10, and 12. And so I'm still continuing with that. And then I'm also gonna making sure that I'm reaching minimum compliance with the 10 state standards. So that's like the Great Lakes, like the Mississippi River Board. And then just continuing off with the textbooks that I have for design. And that concludes the end of our progress meeting presentation. So if anybody has any questions, we would like to open the floor now for those questions. Thank you.
So Jacob, I have some questions. So, you referred to the Lake County standards a few times, but you're in Crown Point, so are you using Crown Point or Lake County?
It's the Crown Point Stormwater Technical Manual that I was using. So I guess I must have misspoken.
Okay.
Yeah.
And then, for the flood control, or sorry, for the water quality volume, it looked like you used the curve number equation, curve number method. I think in there it has a different equation for water quality volume.
For the low impact design method, that was the equation that is specified. There's a different equation for conventional design, but for low impact design, which is outlined in my scope, that was the equation that they specified to use.
What do you mean for conventional design then?
Well, so there's two sections in the Stormwater Technical Manual. There's a section for low impact design and a section for conventional.
It's conventional being not low impact design?
Yeah.
Okay. Okay. And then for the flood control volume, you said you determined a maximum flow rate? From TR, from when?
Pre-development.
Yeah.
Right, yeah.
But you need a volume, not just a flow rate, right? So do you know what the flood control volume is that you're gonna have to store?
Not at this moment. Part of that is, so with the TR55 method, the program, it doesn't give like necessarily a whole volume.
I know.
However,
Yeah.
So there's a function where you can create the structures there in the model, and then it will tell you whether or not that outflow from those structures
Yeah.
meets the requirement. So.
I wouldn't use that
Okay.
because of the assumptions that it makes are pretty poor.
Okay.
So.
That's what it was. So it specified for in the Crown Point Technical Manual. It said for development sites greater than 1 acre in area to use a computer model.
Okay.
So
You can use a computer model to get the runoff, peak flow, and volume, but I wouldn't use that to do routing through your pond.
Gotcha.
Yeah. Okay, thanks.
Okay, Zilmar, so you did the calculation for wastewater generated by a building or two for a parcel or two. So what's your total flow rate of the wastewater being generated for the entire subdivision in this case? Because you're designing a lift station and a collection system, so you're not doing this for only one parcel, hopefully. Otherwise, you're wasting lots of resources for one parcel in there. So what was the overall flow rate? And I know you did the calculation for I&I and minimum and peak, but give me an average number of the overall flow rate, other than having it 5 decimal points. I don't know how you're gonna measure that in the table in there.
Well, Because I wasn't sure how we were gonna use one of the parcels, I did it based off of like a range.
Okay. Did you, how, did you come up, in other words, did you come up with an overall flow rate for the subdivision?
I did not, because I'm still not sure what we're gonna be doing because the only thing we have for sure is the wastewater generated from one building. And so I need to also incorporate what we end up doing for the other parcel. And so I only did alternatives for different uses of that parcel and what it could be. So I don't have like one specific one, I just have like 3 of the different intensities of the overall flow rate.
And how you wanna extrapolate this for so many parcels of the subdivision? I guess you can assume whatever usage, but ultimately, how you wanna figure out the wastewater generated for the entire for the so many lots of the subdivision?
That is something I might have to continue.
Can you go back to that table you put,
This one or?
no, this table? Yeah, because you got like 30,000 liters per day, and that's what was referring to those 5 decimal points of, in there.
Oh,
And so, so this is 30,000 liters. Now we can divide roughly by like 3.78 to get the number of gallons in here. And so how you want to take that number and extrapolate this for the entire subdivision? Because you talked about the pipe sizes. You said going from 6 to 8 to 10 to 12. So how did you get to that without knowing the flow rate?
well, the 6 to 10 to 12, like that range is mostly just, I know at the minimum it has to be at least 6 inches
Okay.
for the diameter, so I just went through like the first.
Okay. I'll leave it there. Alex, I have a quick question for you. That first alignment, or the one alignment you showed in there, if you go to it in there, can you, off the road? Yeah. So why did you decide to go the alignment all the way to the corner of the parcel in there? Is that an optimum type of design? Is that going to be able to serve? I'm seeing your entire south area in here is being inaccessible.
So for the southern area, that's where Josh's road is gonna come in. He's building a road from north to south that's gonna tie into mine. So I was primarily just focusing on the east to west, and as far as making room for more parcels, I tried to keep it as north as possible because we're probably, obviously you're not gonna be wanting to build on wetlands or floodplains. So I tried to keep it north, knowing that we would have access from the south with Josh's road.
Well, I restate my question in there. Isn't that wasting resources? So practically, by pushing your road all the way up, you're not serving any lots on the northeast corner of your property.
That's true. Because the northeast corner is where the wetlands are, I figured we probably weren't gonna be putting any lots in there anyways, because you can't build on the wetlands in the northeast corner of the lot. So that's why I kind of minimized the space up there.
And is that the only alignment you have? What are your alternatives, in other words?
The other one that I'm gonna look at is gonna actually be tying in a little bit south there. As you can see, there's 3 or 4 roads on the right-hand side of the screen there. I'm gonna tie in a little bit further south to, I believe that's Northern Indiana Street there on the right. So I'll be tying in a little bit further south there, closer to that main intersection. That's the other reason I was looking a little bit north, was because that's the main intersection that we're concerned about in the bottom right corner there. Because that's where the highest ADTs are.
Thank you.
Do you guys have a location for your guys' parcel?
Yeah, I think Jacob had that in his thoughts. It's over there. I got it.
So This is the proposed location as of right now for that parcel that we're gonna be building on.
Where is is that like your 1.5 acre parcel, is that your 2 acre
The
parcel?
2 acre parcel.
Okay,
Yeah.
where is the 1.5 acre parcel that your environmental engineer was speaking of? I was just a little confused.
I haven't placed that one anywhere
Okay.
in my designs, but, yeah.
With having 2 transportation engineers, do you have to have 2 parcels, or is your scope having 1 or 2?
So what Professor Grossman decided for us to try and make the work even is, like I said, I'm focusing on the road that's gonna run east-west, and then to keep the work even, Josh is focusing on the road that's gonna run north-south. Where the second parcel comes into play is this building that we're really gonna end up not actually doing, essentially. Josh has to design a parking lot for that and everything. So that's why it doesn't really show up in our water calculations, but it does show up for
So there
Josh's
is 2
parking.
parcels, 1 for each road?
Yeah.
Okay.
I guess a question for Ziramara and Jacob. So I saw you had some B-type soils, Ziramara? And then, did you have B-type soils? And Jacob, because I didn't,
There was some.
oh, yeah, okay, I
That's
guess I
all the
missed
way up
that.
here.
Yeah,
Just a very
okay,
small-
Yeah, very small area.
okay.
And nothing that we're building is, like, the parcel is this area here, and the road kind of goes here, so that's not really gonna be built on at all, so.
Okay.
I guess for Jacob, is the water that's falling north of your road not gonna be stored anywhere for the flood control?
So, this, slope kind of slopes this way generally. And so these contributing watersheds, like if you see there's like a little bit here and then a little bit there, but there's not a whole lot of area on that north side of the road that is actually like contributing to that watershed on the road. Because of that slope. And I used the water drop tool. It's not shown here, but that water drop tool, where the flow paths all kind of went this way.
But you are gonna have to manage your flood control volume, right?
I'm sorry.
You're gonna have to manage the flood control volume for the whole site, right?
Yeah, so what's outlined in my scope is managing the flood control volumes for the development site and the roadway, and then including diversion for water that runs onto the site from the contributing watersheds, but not
Okay, so
falling on the
so
specific site.
weeks ago now, that was changed to be the flood control volume for the whole site, for the whole 50-something acre parcel, not just that site.
Okay.
We were sitting in the fluids lab. Yeah, so.
For the transportation group. Who gets to do that intersection where the 2 roads meet?
So we're not looking super closely at that, to be perfectly honest, from a design perspective, because essentially what's gonna happen at the end of this semester is we're looking at having Josh transition into structures. So pretty much all of the work that Josh is doing on the transportation side this semester is gonna end up getting scrapped. So that's what Grossman told us to do. So that's kind of, we're more primarily concerned about where we're gonna be tying into these roads.
Okay.
You could say it's getting tabled, it might sound better than scrapped.
But to be realistic, I've worked on a lot of projects where your work gets scrapped.
Well, isn't more appropriate if one of you guys did the traffic on an intersection and one on the roads and parking lots, and then as Josh transitions, you combine them into a complete transportation design in this case?
Potentially, we're more or less going off of what Dr. Grossman told us to do. He told us to have me look at a road east-west and also look at a road north-south, so, and then we would be getting rid of the north-south road.
We'll respect that request.
Makes my second question superfluous, I guess. But I was gonna say, you probably ought to consider using the same speed limit on both roads, but since one is not gonna be there, it doesn't really matter, does it?
you guys.
Yeah.